Hello, everybody. Got a few things to go over today. Continuing where we left off the other day, talking about normalization. And at some point earlier in the semester, I probably said we were going to spend 2 weeks on normalization and talk about it. That's what my original plan was. And then I realized that next week there's not going to be a whole lot of lecture going on. Because remember, on Monday is one of our on-campus attendance required days and for this on-campus attendance required is for your group work assignments. So there'll be like a little bit of talking at the beginning, and then mostly it's y'all are going to work in your group. And since that assignment was designed for online group work, you'll probably knock those out really, really quick when you're all sitting in the same room working together. Yes, Charles, question in the chat room. Audio's not recognizing things. When you get the Zoom controls to pop up, I can't share the Zoom controls on the screen, but right next to the microphone or whatever audio thing there is, if you click the little arrow, you should see options of different audio settings on your computer. Well, if he's having audio trouble, I should probably put that in there. Oh, I guess he heard me. Next to the okay, got it. Yeah, it's not in a very obvious spot. I am not a big fan of disappearing buttons. That's like my least favorite thing yet ever. And Zoom is worse than some software because Zoom, the buttons will disappear. And when they come back, they're in a different spot. It's very confusing for those of us that can use that software a lot and see it over and over again. I was talking about normalization. We're going to continue that today. And earlier in the semester, I was thinking we'd spend a couple weeks talking about it. But next week, there's not going to be a whole lot of talking in class. There's group work day. And then on Wednesday, Thursday, and Friday, I'll be at a big meeting up in Indianapolis. 3-day thing going on up there. So we won't have class on Thursday. Probably do my evening class on Zoom, so I'll be back in the hotel by 6 o'clock. But as far as 1 in the afternoon, I'll definitely be in a meeting at that time. So we'll finish up talking about normalization this week or today. A bunch of technical terms. We'll go into the deeper ones, which does bring up another thing. Has anybody looked at the writing assignment for this week? If you looked at the prompt, there was something that wasn't very clear in there, and I just went back and added some clarification to it a moment ago. If you haven't looked at the prompt yet, you've seen it for the first time. But there was on the last little bulleted point in the instructions, it said look up more about normalization, and that was supposed to be the rest of the normal forms. Up to the third normal form, the ones we talked about the other day, those are the ones we want to do every time. We always want to get those 3 in, or as close to the third as we can, because our cascade update and cascade delete, we kind of lose the guarantee that those will work if we're not in third normal form. And that means we have to go through every single table and confirm that things updated when we change. So we always want to get to the third normal form, and that essay has you list out the steps. But for the other 7 normal forms, the ones we're going to talk about today, you can just give a list and a very quick summary on it. Those don't need every step spelled out like the first 3. But if you look at that writing prompt, I did just change it a moment ago, and I didn't realize until the first submission came, so I sent an email to the person that had already submitted it, talking about that, and, yeah, it's what we're talking about today in class. And to finish up reminders, remember the exam is this week, and exams are not on the same schedule as the homework. Please make sure you get your exam submitted by 11:59 on Saturday. Exams are on a calendar schedule. Okay, so there is another thing as we're talking about normalization. So normalization only decreases our storage requirements. So that's really what this does, is it decreases our storage requirements. There's going to be something that shows up as you're doing research on the writing assignment this week that usually isn't written in the clearest way possible. So, yes.
What day did you say the assignments were due this week?
The exact, they're written on them. It's on the calendar.
I thought you said they were due Saturday or Sunday.
The exams due Saturday. Exams are always due a different day.
Was that the midterm?
Yes.
Quick question, did you say you won't be here next Thursday?
Yeah, next Thursday I'm in meeting. I'm gonna be at a 3-day meeting up in Indianapolis. So I won't be here most of next week.
So you won't be here Tuesday either?
I'll be here Tuesday. Yes.
Good question, will you be here tomorrow?
Yes, but I'm in meetings most of the day. I have meetings starting at 8:30 tomorrow, and then I have a few breaks between them. But I'll be around somewhere. If
I
you're
just
on
had
campus.
a question about an assignment from Fire Foundations.
I can try to help with it. I'll be somewhere around, and I have breaks between the meetings. So if you're up here working for a couple hours, there's a good chance you'll catch me in between one of the 1-hour meetings or something.
Okay.
But yes, exams are always on a different schedule in my class. Exams are a calendar schedule, so it's due Wednesday, but I think you already turned it in. So you're good, you're fine there.
Wasn't there one due tomorrow as well?
Shouldn't be tomorrow. So stuff due yesterday, and then stuff due next Tuesday. Might be thinking about a different class. But some normalization. This decreases.
Sorry, I've got a really quick question. Next week, will we know our groups coming out of class Tuesday?
Yes, the groups have been assigned already.
Okay, so
Randomly generated. So let's look at that first. If we go in and we learn.
and if we wanted to, would the classroom be available to come into?
Oh, yes.
Like
So,
around that 1 o'clock to 3:45?
Oh, on Thursday? Yes.
Yes, on Thursday.
Yes, because
Okay.
it's always unlocked. So 158 is the open lab. And since we're normally scheduled here at that time, the room will be empty then.
Okay, that was all. And then, but where are those groups, if you wouldn't mind?
Yes, so if you go into the roster, there's 2 ways to get it. If you go to the roster, you should see a tab for project groups. And I just clicked the randomly assigned one. It looks like you're in the first group. Another very useful one in the inbox, you go to the Ivy Learn inbox when you go to create a new message. Like choose from the drop-down list, instead of typing it, if you go to the choose from section, you should see a student group section where you can just contact just the people in your group. That one is incredibly useful for the group list. Some over in the chat. Oh, yes. Oh, yes. And if you use the phone app, there is specifically a groups. You'll have a great big group button on the phone app. Thank you, Jen. I forgot about that one. Any other questions about the groups? The computer probably auto assigned somebody as the group leader, and that's just because computers do what they do. Somebody told the computer that a group should have a leader, so it automatically assigns somebody. But for all purposes, just deal with that yourself. Y'all decide who the group leader is, and only one submission will be needed for the group. So whenever you submit the assignment, it will be submitted for your whole group. Oh, I did have another announcement. I should do that before we get into a long vocabulary lecture, because those can put us all to sleep, right? So I know a couple people in here are interested in data analytics, right? So I have scheduled that for the fall. So there was some confusion on which campuses were offering which programs exactly. Like all of them kind of cross support things. I think y'all are aware of that, right? I guess they have classes from any of the Ivy Tech campuses. You can take a lot of data analytics from any of the campuses. So there was some confusion as far as who was on the official list, and then there were the official list. There was two different ones that said different things. So we got that cleared up, and here at Sellersburg, we were officially on the list for offering the data analytics CT, which is for that particular one, it's a 21 credit hour CT. So it's about a third of the AAS degree. But and that's not saying the other 2/3 aren't available here, because the other 2/3 are like electives. So your cybersecurity elective and your software development elective. And so the degree would be offered here, but for that 21 credit hour supporting that list, I did get that scheduled now. Starting in the fall, we will have more data analytics classes here. Oh. Bring him in. And I have to stop my screen share to pull something up, because I have to go past something that should probably be, or that might be confidential information. So let me go over here, and then I'll share my screen again and talk about these classes in the fall and spring. Oh wait, actually, no, I have it on a spreadsheet. I'll just show a spreadsheet instead. That's probably a better one to look at than just the blank list. So when I was scheduling it, I went ahead and I made a spreadsheet and just color coded a bunch of boxes so I could see what's in each room side by side to figure out what times to put them and stuff. So that's probably a better one to look at it as far as this anyway. So in the fall, obviously, DBMS 110 is one that runs every semester. Y'all won't need that class in the fall. But during the first 8 weeks, we'll have DBMS 160. That's the data visualizations course. Oh, it's behind the Zoom stuff on the TVs. Get those out of the way. Maybe that'll be out of the way. But DBMS 160 is data visualizations. So Tableau, and usually there's some stuff in Excel because, Excel has charts and tables, but Excel is by far the easiest place to deal with pivot tables. Some of y'all might know what pivot tables are already. If you ever need a pivot table, just export your data and put it in Excel. That is by far the easiest place to make a pivot table. That's the charts and graphs that have filters on them, so you can turn the filters on and off. Tableau, but actually visualizing our data. So DBMS 160 is the class on that. A very, very useful one. And then DBMS 130, that is the SQL course. So that is, we'll see a little bit of SQL here, but we've already seen maybe almost half of what we're going to see, which is create tables and insert data. And we'll only see some simple queries, which is going to be one of the points here in just a moment. But DBMS 130 is the SQL course where it's like a programming course. And since databases are in storage, one way to think of that is that's the program. That's how you program your long-term storage, your hard drive, in order to get stuff over to RAM for the active software that you're working with. And for any SDEV students in the course, I will definitely sign off on that as an elective for your SDEV thing, because that is another programming language that will be very, very useful for you. Informatics 219 as well. So there's DBMS 260. There was on the list, it's DBMS 260 or Informatics 219. And Informatics 219 is business decision analysis, business decision making. So it's kind of like what you do after you get your data out of the database. That part of that OLAP part, you have your data set, all your charts and graphs, and how do you make that decision? So it was an order situation, and a couple other programs needed Informatics 219. So as far as running courses, I decided to go with that instead of the DBMS 260 because it's only an order situation for the data analytics students. Everybody else is, they have a different course, something with their own programming letters on it, or Informatics 219. So it applied in more places. So those are running in the fall. And there'll be more. So anything on the data analytics CP will be running here on campus. Probably as a learn anywhere. And I also just hired a new adjunct to cover data analytics stuff. She's gonna start in the summer. But she's specifically a data person. She's gonna teach some of the SDEV and informatics courses as well, but like one of her master's degrees is in data analytics and the other one's in statistics. So she's going to be teaching most of those data analytics courses and probably most of the DBMS 110 courses going forward. But she'll be starting in summer. And for anybody interested in data analytics, or maybe for software developers that know data ties into your software and want to take some of those courses, they're going to start running on campus here regularly. And I'm scheduling them so they'll probably just almost all be learn anywhere courses. Maybe a couple of them will be blended. Oh, yes, almost forgot that announcement. I figured some people might be excited to hear that. That way you don't have to take all of your data analytics program courses online. You can come to campus some. We have a really nice campus. All the flowers are in bloom today. Hopefully the petals won't fall off by Monday when everybody, or Tuesday when the requirement to be here is. Campus looks really, really nice today with everything in bloom. Is that all the announcements? Performance degradation, normalization. Okay, yes. So now into normalization. And you all have that writing assignment on it this week. So you're going to go do a little bit of research. You're going to see a phrase that when it shows up with database normalization, it does not show up in the normal way. And it's easy to overlook. Because normally, if we're talking about something in software and we're doing research and we see that it says performance is going to degrade because of this, there's an equation or at least a value so we know how much it's going to degrade to go with that other alternative. But when you look at like normalization, like your research for this week, you'll see that. Let's go one up. Performance loss, because I probably misspelled degradation from normalization. And I just want to clarify this because when you see it with databases, they just kind of mention it as a sentence and they don't give a nice little equation that we can calculate how much our performance is going to go down, how much our performance is going to degrade. So I have it here. Hope that one's not very useful. Maybe if I just look up database normalization, I can find one. Database normalization. Oh, the Microsoft page I know says it because for some reason the official Microsoft documentation, even though they have a SQL Server and a couple other types of big powerful databases, their official documentation only talks about access. And move on about that. Second normal form, third normal form. It's probably something. Oh, it's probably up here in the intro there.
I had a question.
Yeah.
when I clicked on the conceptual view example for module 4 assignment, apply normalization, it took me to an example from module 2 assignment.
I'll look into that afterwards.
I'm just curious if that was to another assignment or.
I'll look into that after class. It might be the same example. Oh, there it is. I knew it was on this page somewhere. It may degrade performance. You'll see that, but not in the normal way we see it, right? Usually if something says degrade performance, it tells us how much it degrades. And that's because the performance degradation we will give to normalization is not a computer thing. Normalization is all about storage. Let me pull up that example from the other day. I know I was going to talk about this, and when I double checked, I didn't save the example the other day, so I had to recreate it. It's the same example I always do, so it wasn't hard to recreate it, but it decreases our storage requirements. When we normalize our database, we're using less storage space. Oftentimes, the diagram representing that database will get bigger, but the picture has nothing to do with the database, right? That's just the way to interpret it. So if I go generate the code from this, we looked at this software the other day, checked everything. Universal SQL, and just output it. Here will work. And talked about this the other day, this software ideas modeler. It's kind of some high-end diagramming things and lots of other tools. Very, very useful. You get a 30-day free trial, and we're about 30 days from the end of the semester. So what's in our open with? Wait, that's weird. Let's go to the text editor. I don't know where my open with button went. We're about 30 days from the end of the semester, so if you want to try that high-end diagramming and generation software, it'll probably last till about the end of the semester now. I just open these up. So we get our create tables, but they don't mention the foreign key that was in there. And when we look at the foreign key, over in that picture, which I already closed, I put it with the named person ID. The same thing it was in the original table. But when it adds it in there, you can see that it did not keep the human name for that. DF. I don't see anything after F, so that's probably hexadecimal. But it set that up as machine code, binary instructions. And the text editor needed to do something, so it threw it out in hexadecimal. But it didn't create the foreign key as that a new field, right? It didn't make a new data field in that table called person ID and then put the same data in it. It gave computer instructions, which basically just points back at the other table. So when it shows up in our diagram, we see it showing up in both places. But in the database itself, it's only referring to the one place. So it cuts down our storage requirements, and only having one place actually cuts down our write time. So when we go add more data in, it's quicker to add data to insert data. Reading data, there's no change because if we select a data set from our database, we're selecting the same data no matter what, whether it's normalized or whether it's just in one giant poorly organized table, we're retrieving the same data either way. So read, there's no change. And that performance degradation, I guess technically there is on the computer side, and that a very nicely normalized database will require a more complex query to grab the data out of it. Which means that we have a longer text string that needs converted into binary code for the machine to actually work with. So that conversion from a longer string into binary will add a few microseconds to it. While you see that everywhere, that is a human performance degradation. So right there, that should tell you that's a big deal. It's not the machine, so faster machines aren't gonna help if the human, because of those more complex queries, the database administrator has to write harder queries, which means they're gonna have to spend more time thinking about how to put them together and then write a long string where they're more prone to make a typo in opposed to a very simple query where they can knock 3 or 4 of them out really quick without making a typo and barely have to think about them. When they have those big complex join queries, and we'll talk about joining soon, it's gonna take them a little bit longer to think about what to put there. Then it'll probably take a couple of passes to get it put together without typos. So that performance degradation is a human performance degradation, which means it's gonna happen on human timescales, and better machines aren't going to help with it. So we get advantages, but your database administrators are gonna move a little bit slower. That's sort of the trade-off there. And you'll see it everywhere, and it's a lot of times it's not explained very clearly. And when people do early research into normalization, they misunderstand that. Think that it's something that's worse for the computer. It's like, why do we spend all this time doing this and learning this in class if it's worse? But it's worse for the database administrator, not for the machine. So usually when things are worse, at the absolute worst case, we could just get a faster machine, and then it's not a problem anymore. Right? The Apple method. Apple's traditionally do something better with graphics, which means they have to be a bigger machine. But the trade-off for that is that there's a bigger machine for all the stuff that doesn't need that bigger stuff. And so Apple's have this really nice reputation of being a faster machine, but that's really just because of something they do that requires them to be a bigger machine in one aspect. But then that bigger machine translates through to the stuff where that aspect's not needed. Database normalization is not like that. It's harder. It makes it harder. It adds work to your database administrator. And granted, that database administrator is going to know it, so they're not going to have to spend hours digging through documentation to figure out how to put a query together. They know what it is. It's just more complex than if they just said select all from this table and select all from table 2 and select all from table 3 and then filter it afterwards. They have to write a big complex thing that says select these items from table 1 and then this item from table 2 and use it with an item from table 3 to calculate a value that we actually want to return. So just wanted to make sure and clarify that point before you all get into that writing assignment. That often confuses people right at the beginning, because they'll do their first research into normalization and be like, why does this keep saying it's worse? But it's not worse for the machine, it's better for the machine. At most, we lose a few microseconds because we have a longer string from the text file that we need to turn into binary code. But our write operations are usually quick enough that it more than makes up for that. So with that said, we got up to third normal form. And when you do the writing assignment, the bullet points are very detailed on 1NF, 2NF, and 3NF, what we talked about the other day. And for assignments in this class, now that we've talked about it moving forward, that's the expectation that any ERDs or database schema that you submit are going to at least be trying to get to third normal form. We want to go at least that far, but it does go further. And it really, really optimized. But it's always a situation of how far do you want to take the normalization. As a rule of thumb, you always want to go to third normalization. Going further than third normalization, you want to weigh the situation. Its advantage is advantageous storage-wise. Let's take a cloud example. If your database is run on the cloud, you're going to pass it through a server to handle all the instructions, and that server is going to come at a fixed cost. But storage has variable cost. And in particular, storage like you would use for a big modern database, the cost on that is going to be charged by the gigabit, which is a prefix that a lot of y'all probably don't even know right now, right? Anybody know how big a gigabit is? Gigabyte is what, yeah, we charge by gigabyte. I'll just probably show both numbers, gigabyte versus gigabyte, because you all know what that one is. So, a gigabyte is 2 to the 30th bytes, whereas a gigabyte is a gig. Okay, that result says 10 to the 9th. Giga is billion, so it kind of relates to the same. So giga is billion, but a gigabit is 2 to the 30th power, which is that many bytes. A little bit bigger, but a bigger number. Instead of 2 to the 9th, like we usually measure, it was measured 2 to the 30th, and that's what we charge for. So we're talking about big storage sets. Okay, this we're learning the concepts for the large business situations that pay really well. But before we talk about further normalization, we have to talk about a little bit more about keys. Because so far we've pretty much only mentioned primary and foreign keys. And that will be enough for definitely anything in this class. Just having a primary key, that auto incrementing integer, if there's not something obvious, that will get you up to the third normal form. But when we take it further, we need to look at some other stuff about keys. So let's start there. I thought that was a new marker. I think the blue one was working. And I did go ahead and throw primary and foreign key on this list so you can see where they fit in that, where they fit in the overall scheme of keys. So super key is a set of attributes that uniquely identifies each record. That's a very general one. Let's look at this like it would appear on a table real quick, so you can kind of make sense of what's going on here. So if we had a bunch of people, make a people table real quick. If I can spell people correctly. I don't know how many rows we need for exactly in one cell, and make it blue, and then we'll add our columns in right below it. Without getting to skipping an integer ID, because that's a quick, easy one. That's a quick, easy one when we don't have anything else. So we're gonna have like first name, last name, number. What's the word for like junior, senior? Isn't there a technical term for it? I'm just gonna go with number, but junior, senior, because right, some people have a number beside their name. Some families get up to lots of numbers. My older brother has lots of numbers beside his name.
You mean like
family
generation
Yeah,
or year apart?
just the term for the numbers, like junior, technical term for what junior would be, but number would be fine for our purposes. I just gotta remember what the name is. So that's gonna be like junior, senior, first, second, third, 16. Some families carry that on for a long ways. Then we have an address, right? I'll say address, city, state. Oh, I was one field one block short, let me merge those into one thing.
By senior and junior, did you mean like how some relatives are named after one another?
Yeah, there's stuff like that, but I couldn't think of a good label for that column. So we got this table set up and we can add some information. Maybe we have a George person,
I
junior.
just thought of something funny when you said that legacy name. You know, because in comic books and TV shows, some characters take on the name of other characters.
Yeah. So we'll have a bunch of data like this, right? Susan, human, and leave that blank. She lives at 444 Avenue. Place in Kentucky. Jimmy, at 111. I'll go with Market Street because there's a Market Street in like every city in America. City, Indiana. But we'll have stuff like that. Just a quick example. And let me do some quick duplicates in here. So like George, someone, the third, lives at 555 5th Street. Made up place, Kentucky. Susan, someone, also lives at 555 5th Street. Made up place, Kentucky. Zoom in. Yeah. So that way it's a little bit bigger on the screen. So skipping the unique ID integer that we normally do, can we still uniquely identify every record? Or any of those records duplicates? I got another one.
Oh, quick question. If we're doing that generation name thing,
Mhm.
do we need to do one like, say, if they're a doctor as well?
It depends. Don't need it for this example. The details like that would completely depend on the situation you're in.
Is that module 4 assignment apply the normalization process? Is that done in Excel?
It's a writing assignment.
Apply the normalization process?
We can look at the homework assignments after class.
Okay.
So let's say we have a data set like this. There's no unique ID field like we've been using so far mostly. But can we uniquely identify every record? Do we have any duplicates? Okay. First name would be a problem. First name isn't enough to uniquely identify everything. And same thing with last name.
You more have to count them together.
Yes, exactly. We have, so any individual field isn't enough to uniquely identify everything, but several fields together. So one possible super key would be first,
And last name?
address, state. Yeah, that might be another one. First, we would need first and last. First, last address. Those would be a couple possible unique identifiers. Let's put George Senior in here.
I just remembered another one that could be used for that. Alias.
Alias would be like a nickname.
Oh,
I know there's a technical term for it. I can't remember quite what it is. So here we would need now that we have junior and senior both living in the same house, we need the first, the last, the number, whatever that should actually be called. Because if we just call that field number in a real database, people would, that's an ambiguous situation. Different people could take that differently. Number and address, and that would probably be enough. We might need city. Could add city in there. Not sure if we need it or not. But those would all be super keys. Those things put together make a unique record. So our key does not have to be an individual field.
Roman numerals?
If we write them that way,
I
yeah.
looked it up and that's what it gave me.
Because junior and senior wouldn't be written with numerals. Nobody writes 2 or 1.
Well, I mean, some people, when they do that junior thing more than once, they include the third.
Yeah, it'll be okay. That was just for that column header. I guess putting number there works to remind you about the ambiguous part, because if people see number as a column header, everybody's gonna take that differently. So you wanna make sure you have the right term.
I mean, if you use the same name for more than 2 generations, they start to
Yeah.
have a number.
That part really doesn't matter. The rest of that is just the super key. It's the set of attributes. It doesn't have to be a single attribute. As long as there's something that uniquely identifies each record. The candidate key is a special super key, which is the minimal set. Minimal super key. So the absolute minimum number we need to uniquely identify each record. So in this example, what is our minimum number?
1 and 2?
What's the minimum number of fields we need?
Uh,
So first address state, that's the smallest on this list. Or first list, last address, that gives us 3 things. But again,
Phone number?
3 wouldn't be enough because we have that George Person Senior and George Person Junior. That would be a unique thing, but it's not in our table. So we need something from this table. And we just need the number of them. So 3 is not going to be enough. First, last number, address, city. That's a super key, but I think that's more than we actually need. I think we could drop city from there and get by with just 4 things. Candidate key. First, last number, and address. In this case, would be enough to uniquely identify every record as well as every record that we had afterwards. Right? A primary key, if we wanted to do it in one field for some reason, but that's not a requirement. As long as we have something. So it looks like a four-part key is the smallest we can get without adding something specifically to be a single field unique identifier. Because we do this to save space, right? So adding a field just to create a unique identifier is the exact opposite of saving space. That's wasting space. We have from our data set, we have a way to uniquely identify everything. That's what a super key is. And when we take the smallest number of fields possible, we get a candidate key. Then we get to primary key. I hope I didn't misspeak a second ago. I was trying to be very, very careful not to use the word primary key for unique identifying field. That unique integer ID would make a great primary key, but what a primary key is a specific choice of candidate key. Choice of candidate key. That's what it's gonna be on a multiple choice quiz. Make sure it's specific choice. Put that in normal English, let's say a labeled candidate key. That's where we take that minimal super key we found, the smallest number of attributes needed to uniquely identify something, and put a label on it that specifically says, this is our important one. This is our most important candidate key, because if we start looking at data sets, you'll find there's almost always going to be more than one. There's going to be lots of super keys, and then we can break those down and minimize them, and we'll often come up with multiple combinations that give us the same number. So we choose one of those to be our most important. That's where primary key fits in. And the easiest way to do it, something that will get us up to third normal form every time, the one we want to make sure and get to, because it does help with storage a little, not like the 6NF that we'll get to in a few minutes. But if we don't get to third normal form, we can't really rely on cascade update, cascade delete, which means we have to dig through the whole database every time we have to make a change and confirm that that change happened like it was supposed to. So we always want to get that part. Foreign key, I'll put that next on this list. Foreign key is a reference to a primary key from another table. That's why I actually had that, was going to pull that thing up earlier today. We've talked about that before, but there's a good example of what that means from this generated code. And one of these, a food reference. So this right here, we don't repeat the key. We don't store it again in the second table. We put up a bunch of machine language instructions that refer to the one we stored in the first table. So it's just a reference to the primary key, whether that primary key is one field or 7 fields. We can create a reference to it, and that's what ties our database together. We've already seen that. As far as classwork, we're probably going to use auto increment integer IDs and use those as foreign keys, and that will easily get us through the introduction to data analytics course. But for those, especially those heading into a data analytics major, you might want to take it further. And for software developers, if your software is to work with a massive data set, you might want to take that a step further sometimes. It very much depends on the situation. I mentioned that degradation in performance that we'll often see referred to in the reference material is a human scale. So if all that degradation happens to the programmer when developing the software, it's going to be a lot better once that software is released, because then it won't be a human doing it. It's just a bunch of code running in the background. And then we won't have that degradation anymore. We'll just have really good storage capabilities from our software. So every situation is unique. You kind of have to reevaluate how far to take normalization every time. But always go to third. Always make sure you go to third. Alternate key. Okay, another marker gave out on me. Let me try red. I have more markers in my office. I'll grab some after a break. And yeah, when we talk about the other 7 normalization layers after a break here in about 10 minutes, we need to know about these keys. Because the sentences about them aren't gonna make much sense until we know what they're talking about with the keys, because all we've seen so far and what we're gonna use in class is the integer primary keys and the foreign keys. That'll get us through class, but we gotta see the other stuff. So an alternate key is a candidate keys. Candidate keys that are not the primary. Candidate keys not selected as primary. Which in normal English is going to be the opposite of the primary key. It's our unlabeled candidate keys. Couple more. Is it okay if I erase the first slide before we move the camera? I see head nods here in the classroom. I'll give it a second just in case anybody needs to take a screenshot of the Zoom call. Okay, well, it's recorded. I guess you can always pull up the video and take a screenshot of the video later if you need to. So next is one that a lot of people, or the next two, a lot of people think are synonyms coming in. So synonyms in normal English. The next up is our composite key. Does that keep falling off? So that lid in there real good so it stays. And that is a candidate key made of two or more attributes. Made of two or more attributes. We kind of like that one we just saw. The example we just saw, those were all composite keys. However, none of those were compound keys. A compound key is a composite key where one of the attributes is a foreign key. So at least one of the attributes comes from another table. Composite key where at least one attribute is a foreign key. One more on the list of keys. So composite and compound are synonyms in English, but they are distinctly different. Composite keys are all from one table. Compound key, at least one of your fields comes from another table. I haven't graded last week's ERD, but I previewed it, and it looked like just about everybody had a compound key in there. I think it was the orders one. Might have been some on the students' keys as well, where you'd have well, I guess it showed up in the student one as well. You'd have just about everybody had a student ID and a course ID in that bridge table. That would be a compound key because both of those were foreign keys and both of them are necessary in order to uniquely identify that particular record. So it is a candidate key. Because we couldn't uniquely identify any of those records by one of them alone, right? The student ID shows up in lots of those, and the course ID shows up in lots of them, but that combination starts to make it unique. Actually, we probably need a third thing in there to make it a full candidate key, wouldn't we? Because Oh, wait, no, that would be enough. The two would be enough because the same student's not gonna take the same course twice. I might retake the course, but that would be a different course ID. Right? When it runs next semester, that's a different ID. So the two would be a compound key. Both of them are foreign keys. And it takes two, so they are a candidate key. And the last one is going to be an elementary key. So there's a mouthful here. I'll summarize it first. We don't need the whole record. So part of the record. So everything up to all the keys up to now were for that entire record, the entire row in the table. But maybe we just want part of that record. We know we don't need the whole record. And an elementary key that's where we use those. So part of a composite or compound key, obviously depending on her situation, on which some attributes in record depend. Wait, that's not a great sentence. Cross some of that sentence out and try that again. Part of a composite compound key where some attributes in the record depend on it without relation to the rest of the compound or composite key. Where some attributes in record have a functional dependency which, that's the word I'm looking for there, which some attributes in the record have a functional dependency on without relation to the rest of the key. Without any relation to the rest of the key. I'll write it that way, but hey, to avoid trying to write composite compound again. So that was a mouthful. Hopefully, if you think about it for a very brief amount of time, you'll realize why that's important. In our table here, our quick example, for most of the examples, we did not need that number field. Right? 3 would have been enough, except for that one household where junior and senior still live, George Jr. and George Sr. still live together. For that one, we had to have the number. So, other ones, first name, last name would be enough of an elementary key for the two Susans. So notice it changes record by record. But Jim, first name would be enough of an elementary key for that. So there's only one Jim in the thing. Probably meant to write Jimmy there, but there's still only one of them. So we only need the first record first. We only need one field to identify that. So that would be an elementary key. So a whole bunch of keys. Take normalization concept further, we'll need the rest of those keys. And an important thing there is to break away from that auto incrementing integer that we've used so far in class, and we're probably going to keep using in class because that's fine for a classroom. It's quick and easy, and we don't have to waste all of our precious time in an 8-week course trying to think of a key. But it does extend beyond that. We have multiple fields, that whole list. And on your writing assignment, you're going to want to work those in, right? That's the vocabulary for this subject. So when you're writing about the normalization process, that's going to depend on different combinations of the keys. What we're going to talk about after a break. So super key, candidate key. Super key is a set of attributes that uniquely identifies each record. Obviously, there's the trivial case there is the obvious one, right? Obviously, if every record is unique, then that entire record is a super key on its own. But we don't want to manage our database by considering the entire record, every entire record as a super key, because that would get very, very confusing. That's the whole database, and at that point, we might as well put it all in one giant table, because we have to use everything every time. So candidate key is the minimal number that we need to make a super key. The minimum number of fields we can put together to form a super key is the ones we're looking for. We can have more than, we will usually, almost always, it'll surprise you when you can only find one. So there's usually several candidate keys. We will label one of those as the primary key. Because then that connects to our other tables. And when that primary key shows up in another table, then it's a foreign key. And all the ones that we didn't label as our primary key become alternate keys. Then a second categorization. That's why I was careful about where I erased the board. The second categorization is the composite key versus the unique key, which would be the single field. The composite key is 2 or more fields. A compound key is a composite where at least one of those fields comes from another table, or at least one of those is a primary key in another table. And then an elementary key is the portion of a composite or compound key that we need for a specific situation, not for the database in general, for a very specific situation. So lots of keys, but they show up in the rest of the normalization stuff. That brings us to a good PowerPoint. 10 minutes sound good? I see big head nods here in class. I assume similar thing on the Zoom call. So my laptop says 2:03. We will get back to it at 2:13. I'll see y'all in just a moment.